In this paper, a new application for transmitting image notifications on the FM radio broadcasting infrastructure dedicated to warn drivers about significant road events and to increase the traffic safety is presented. The structure of the application includes an FM broadcasting station, which transmits the image notifications, the driver receiving device represented by a simple tablet PC, and an RTL SDR device connected to the car antenna and USB connected to the tablet PC. The paper analyzes different technical solutions suitable for transmitting and receiving real-time image notifications in different scenarios by using the software-defined radio concept. In this figure, the number of road fatalities per million inhabitants in the European Union countries in 2019 are presented. According to this chart, Romania occupies an undesirable first place. Here, the total number of road fatalities in the European Union countries in 2019 are presented. In the context of these worrying figures, our application will contribute to the increased traffic safety. The database of images for traffic events notifications is represented by black and white images of small dimensions. Some examples are illustrated in these figures. Notifications appear on the car's tablet to signal a traffic event, as can be seen in these figures, as well as in the next demonstration video. In the first scenario, the image notifications are QPSK modulated and transmitted with 8 kilobits per second bitrate by using a mono FM radio channel. In order to increase the speed of data transmission, the second scenario uses a FM subcarrier channels dedicated for broadcasting alternate services. In this case, a QPSK, 8 PSK and 16 PSK modulations can be used to transmit image notifications by using a stereo FM radio channel. In this table, the parameters of all transmission scenarios analyzed in the paper are shown. The signal-to-noise ratio of the received RF signal is measured by using a software spectrum analyzer from MATLAB Simulink. This value is required to plot bit error rate versus EB-to-N0 ratio in order to characterize the digital transmission performance. In this figure, the bit error rate, depending on EB-to-N0 ratio, for all digital transmissions analyzed by simulation in the proposed driver's warning application, are illustrated and compared with the corresponding theoretical values.
On the hardware side, the proposed solution can be easily implemented into an existing FM broadcasting system. In order to validate the results, we have built this setup by using one of the experimental facilities of City Laboratory in Lyon, in France. The scenario of transmitting the images through QPSK modulation was implemented and, in order to get as close as possible to a realistic transmission scenario, we included an homemade RDS generator in the signal path. The classical broadcasting architecture for a commercial FM station is shown in this picture. With the employed modulation technique, the data corresponding to the image can be added directly into the monophonic audio zone. A radio data system encoder can also be used in order to keep the compatibility with the existing infrastructure.
By performing wireless transmissions on a FM radio channel, we have studied the coexistence of the three kinds of signals: the audio, limited to 5 kHz bandwidth, the QPSK, corresponding to the image transmission, and the RDS1. More precisely, the audio and the data signals were built in MATLAB as a WAV file, which was played back by a smartphone. The RDS signal was then added by our encoder, which may be programmed via a PC interface. The arbitrary waveform generator ESG4438C from Agilent performed the FM modulation of the radio frequency carrier by using as modulator the composite signal. Then the obtained RF signal is emitted by this omnidirectional antenna. At the receiver side, we have used the RTL2832U dongle, which was set up in MATLAB Simulink. RTL SDR book library allowed us to decode the images, and the RDS tool allowed us to decode the corresponding RDS message. In order to test the compatibility of our approach, with the commercial FM receivers, we have used as a sniffer this radio receiver. The audio and the RDS signals are properly decoded, as can be seen here. One of our concerns is to find a compromise between the quality of the received image and the sound quality. Consequently, a study of the bit error rate as a function of the QPSK's signal level was performed. In this figure are presented bit error rate values obtained experimentally depending on the EB over N0 ratio presented in this table. The ideal theoretical values of bit error rate versus EB over N0 ratio for an AVGN communication channel are also represented. According to the obtained results related to the power levels, the measured bit error rate variation are coherent with respect of the theory.
With the proposed system, we demonstrated that our approach is suitable for an integration in the existing FM broadcasting infrastructure. We hope our application will contribute to make a safer car traffic.